All right, let's talk about something we all use every single day, software. We're going to pull back the curtain and look at how it's really built. What's the one thing that stands between a brilliant idea and, well, a total digital disaster? Let's dive in and find out.
You've definitely been there, right? That feeling of pure frustration when that brand new app you were so excited for just doesn't work. It crashes all the time, it's super slow, or that one key feature is just gone. Turns out that experience isn't random. Not at all.
In fact, there's actually a name for this problem. For decades, the people who build this stuff have called it the software crisis. It's this persistent, nagging challenge of making good software that actually shows up on time and doesn't completely blow the budget. And it's the one problem software engineering was invented to solve.
So here's how we're going to break it down. First, we'll look at this lingering crisis. Then we'll get into what makes software so different that it has to be engineered. After that, we'll walk through the blueprint they use, uncover the shocking cost of just one tiny bug, and finally, we'll bust some common myths that can sink a project before it even starts.
Okay, first up, the lingering crisis. Let's really get a handle on the scale of this problem. Why is building great software so consistently difficult?
The software crisis isn't some new thing. We're talking for more than 35 years. It's been this shadow hanging over the entire industry. And it's always defined by the same three failures. Projects are late, they cost way more than anyone planned, and in the end, they're just not very good. Sound familiar?
So if everybody knows about this problem, what's the fix? Well, it all comes down to treating software like a serious engineering discipline, not just some piece of art. And to really get that, you got to understand what makes software so weird. How is building an app any different from, say, building a car?
Now, this is really fascinating when you break it down. A car, right? It's a physical thing. You manufacture it from steel and rubber and glass. But software, it's a logical system. It's intangible, made purely out of ideas. The cost of a car is mostly in the materials. The cost of software, it's almost all brain power. It's the people. And here's the biggest difference. A car wears out. Software deteriorates. It doesn't rust or break down physically, but it becomes obsolete as the world and technology change around it.
So, here's the takeaway. You would never, ever build a bridge or a skyscraper without a detailed blueprint, right? Without following the proven principles of civil engineering? Well, the exact same logic applies here. To beat the software crisis, you have to bring that same level of discipline to the digital world.
And that brings us to the blueprint itself. In the software world, it's called the Software Development Lifecycle, or just SDLC. The best way to think about it is as a structured roadmap. It's designed to bring order and predictability to what can be the pretty creative chaos of building something from nothing.
The SDLC breaks everything down into these really clear stages. You start with high-level planning. Then you dig deep into requirements to figure out exactly what this thing needs to do. Next up is design. That's your architectural blueprint. And only then, after all that prep work, do you get to development, the actual coding. After that comes intense testing, then you deploy it to your users, and finally you have ongoing maintenance. It's a deliberate process, you see, not just a mad dash to write code.
So why is it so important to follow a process like this? Why is it totally non-negotiable? Well, it all comes down to the absolutely mind-blowing cost of making a mistake. And where those mistakes come from, it's probably not where you think.
Okay, get this. Most of us think bugs are just, typos that programmers make while they're coding. But the data tells a completely different story. Nearly 2/3, a whopping 65% of all the mistakes in a software project happen way back in the earliest stages, in the requirements and the design. This is before a single line of code has even been written.
And this chart just perfectly shows why that is so critical. If you find a mistake during the requirements phase, let's call the cost to fix it 1x. Easy peasy. But what if you miss it? Well, find it in the design phase, and it's suddenly 5 times more expensive. Wait until you're coding, that's 10 times. By the time you catch it during testing, it's 20 times more expensive. But, and this is the real kicker, if that bug makes it out to a real customer and you have to fix it in maintenance, the cost can be over 100 times what it would have been at the very beginning. It's an exponential curve of pain, and it is the single best reason to get those early steps right. And speaking of maintenance, let's just bust a huge myth right now. When we hear the word maintenance, we think of fixing things that are broken, right? But in software, that's only about 20% of the job. A massive 80% of what we call maintenance is actually enhancement, adding new features, adapting to new operating systems, and just evolving the product to keep it useful.
Which brings us to our last section. You can have the best process and the best data in the world, but software is still built by people. And people can fall for some very persuasive and very wrong ideas. So let's debunk some of the biggest myths out there.
First up, this is a classic you hear from clients. It's that urge to just say, hey, just start building. We'll figure out the little details as we go. It feels like you're moving fast, but really, it's a huge trap.
The hard reality is, filling in the details later is just another way of saying, let's intentionally create problems in the requirements phase. And as we just saw on that crazy chart, those are the most expensive, most damaging problems you can possibly have. Being vague up front is a surefire way to fail down the line.
Okay, next, a favorite from the manager's playbook. The project's falling behind. What's the logical move? Just throw more people at the problem. That'll speed things up, right?
Well, in reality, adding more programmers to a late software project almost always makes it even later. Think about it. The new people have to get up to speed, which takes time away from the team that's already working. Communication gets way more complicated. Without a solid plan to guide everybody, more people just create more chaos. A disciplined process is what delivers projects, not just more bodies.
And finally, here's a myth from the actual developers themselves. It's that amazing feeling when the code finally runs without any errors and you think, phew, my job is done.
But as we know now, that could not be further from the truth. Getting the program to work is the starting line, not the finish line. I mean, when 80% of the long-term work is all about enhancing and evolving the product, launching version 1 is really just the beginning of that software's life.
So, let's wrap this all up. If you only take away 4 things, make it these. 1. Software is engineered, not just coded. It's a real discipline. 2. A structured process like the SDLC is absolutely essential. 3. Most of your problems start in the very first stages, requirements and design. And 4. Finding a bug early isn't just a small win, it's a massive exponential victory.
So I'll leave you with this final thought. The next time you open an app on your phone, whether it works perfectly or it crashes right in your hand, I hope you'll see something a little different. Not just the buttons or the code, but the entire engineering process that was behind it, or maybe the ghost of one that went horribly wrong. Thanks for watching.